Hi there. So tonight I want to talk about this question, 65 valid number. So it's the question statement is quite simple. Given a string, we want to determine whether the string can be interpreted as a decimal number. Here are a whole bunch of lists of examples about what counts as a decimal point, what's not. You have your integers, fractions, some ABC, which is if we are dealing with hexadecimal, it might be okay, but in this case, no. A space in between and an invalid character here, so that's false. 10, 2e10, which is 2000. No, not 2000. 2 multiplied by 10 to the power of 10, quite a big number. Negative 90 multiplied by 1000, that's also a valid number, valid decimal number. 1e what? So it's missing digits after the exponent, so it's not valid. E3, but you don't have the number in between before e, so it's also false. You get the idea. So it's your typical common sense kind of notation for the decimal numbers, both the most used and a little bit more scientific kind of notation here. Both are supported, so the code should support that. Just a quick note here. I find I guess in the test cases there are situations like 5 point or 0.1, those kind of cases. I personally use this quite often for point something. I use this for my thresholds probabilities in my code. If the log out, if the probability is over 0.5, I classify this as something. So for that threshold, I use point. Just being lazy not to type the extra 0 before that. And 5 point is sometimes in the programming languages. I want the number to be actually of type float. But the number is just looking like an integer. So I just add a dot to force the programming language to treat this like a float. The compiler or the interpreter, not the language itself. But you get the idea. So these two are valid notations, and I think the test cases in Leetcode actually has those. So I think our code should support those as well. That's pretty much the question. Here it says that the statement is ambiguous. We should gather the requirements and just asking questions about what should we cover, what we don't need to worry about. Ask a lot of questions before we actually code anything. But in this, in my setting, it's not interactive. Just me talking, and nobody on the other side in real time. So I'm just going to take all this as a given to me. So here are the list of the things that could potentially we need to deal with in the string when determining the decimal point, which are the digits 0 to 9, exponent, the character e, plus and minus sign, and a dot. So that's pretty much I think they're missing one thing. That's the empty space. The empty space are okay if they are placed in both sides. So if it's beginning with some extra white space or end with some extra white space, it's okay. We could either call a trim, or in the code we're actually dealing with white space as well. Both are fine. So that's pretty much the question. So this is the time that when we pull out the regular expression kind of knowledge. If you still have that, you use that daily, not daily. Often you might still remember that. It's actually quite simple. So I'm gonna just note that I'm gonna use regular expression, but I'm gonna convert that into some other kind of code that doesn't require the regular expression library, because I guess in interview time they may say, hey, you shouldn't use, what if you can't use regular expression, what would you do? So I'm going to talk about that after the regular expression kind of a solution. So just in general, what kind of string are we expecting? I'm just going to use an underscore to represent some empty space here. So in the full list of possible kind of a thing, the valid decimal number string which contains all the possible elements in there, it's going to be, I'm just use that as an example here. So it will be some extra space in the beginning, and we have maybe like a positive sign, and then some number, a dot, some more numbers, and exponent character E, and some other numbers, and then we got a bunch of extra space in the end. So that's the possible, valid decimal number string, which contains pretty much all the possible stuff in there. So just quickly look at the thing here. We have extra space in the beginning and end, which are optional. Optional. Let me actually use this to indicate that it's a it's a group kind of thing. And the plus minus sign here is also optional. We've got some digits here, which can be 0 or more actually. And it's also optional. It could be optional. And we got a dot, which is also optional. But if we have a dot, then it must have at least a digit. So I'm gonna put this here. So the dot is optional, but if we actually have a dot, we need to have a digit. How do I represent that? Yeah, it's this. The two things combined, it's optional. So we either have no dot or we have a dot and the digit afterwards. And some more digits. Sorry. And we got a E here. The E part is also optional. So the whole chunk is optional. We got a E here. We got a optional plus and minus sign, and we got some more digits. So by analyzing the fullest possible valid string, decimal number string, we pretty much come very close to the actual regular expression pattern that we're going to use. So I'm just going to use a new line here to code the pattern. So it's we begin with some extra space. It's 0 or more white space in there. We got an optional sign in the beginning, and then this I think this is a little bit sloppy. I should actually break this down here, the digits here. Let me code the easier part first, and then come back to this. So just leave this as open and closing brackets there. I'm gonna revisit the stuff here later. So we're gonna end with potentially some more white spaces, and we have one optional section for the exponent. So it's exponential sign and potential sign and digits. It has to be at least one and can potentially be many. So that's that part. Here we can have 0 or more digits, but there are two cases here. One should capture the 5-point case. The other one should capture the 0.1 kind of a situation. So it's a OR here. And for the first one, it will be a digit, some digit, and a dot. But the dot is optional, so we can have the pure integer cases like a 5, 0 or something, and this first the stuff before this OR here, it's capturing that, like 5.4, 55.3. Something like that. The stuff before the dot will be captured by this pattern, and since we have a 0 or many digits here, after this OR here, it should capture all the remainder fraction number there. The other case is that we actually start with a dot, and then it's mandatory that we have to have at least one digit after the dot, because if you just have one dot there and then directly followed by E, it's not okay. So that's what we put here. So a dot and immediately followed by a digits. So that's the pattern. Let me quickly check if I made a mistake. Yep, I think it's the pattern here, and for this problem's purpose, we just try to see whether the input string matches this pattern. So that's pretty much the regular expression state solution. Let me try to run it. This is some of the test cases that I put in there. Let me actually put more. 0.0 0.1 yeah, so let's submit this. So it works, and you can see that we actually have quite a few different kind of like a state here, internal state. If you think about this regular expression, whether we are still marching the initial empty space, or we're dealing with the possible negative positive negative signs, or we are in the big here, which is a little bit complicated about the actual number there. And or we can, once we process the number, we find E, then we enter the territory that we have to deal with this whole thing about the the scientific notation E exponent stuff here. And once we finish that, we can, if we see an empty space, we then enter the phase that we're dealing right towards the end. If there's nothing but empty space in the end, we can pretty much say that this number is a valid decimal point. So there are a lot of intermediate kind of state here, and based on what kind of a character, what kind of symbol you see, you can potentially transform into either the intermediate next state, or you could jump into the possible next state. So if there are options here, optional state here. So every regular expression can actually be can be understood by making a finite state machines here. So if you don't know finite state machine, it's a just think about this as a graph. You have a lot of state, like the initial state, or we're dealing with the positive sign or negative sign. We're dealing the actual number there. We are dealing with the exponent there. Those are the state of this regular expression, or this code in general. And there are the letters are considered to be the edges that's linking between different states in the program. And it's a directed graph, and it can tell self loops. You keep seeing the same digits, it's repeating. That's what the asterisk here or the plus sign here says. When you see repeating digits, you're just looping back to itself, the state itself. Yeah, so I'm doing a terrible job explaining this, but the thing is that if we are not allowed to use regular expression, we can pretty much code up the state machine, or you can just think about it as a directed graph. And actually, in this question, since last night I talked about the topological sort. If you think about this one, and you ignore those self-pointing edges, this is actually, you can derive a topological ordering on this graph if you build it as a directed graph. So let's talk about how we can code up this finite state machine. Basically, for the finite state machines, you will have a transition function which here I'm just gonna use a matrix to represent. Each row is gonna be the state, and each column is the input, which it's pretty much what you see here: the digits, exponent, sign, decimal points, and empty space, and some invalid stuff like ABC. So I'm gonna lay out the matrix here. So just use some comments to see which column represents what input I see. They are pretty much the edge in the directed graph. So we have space. Let's actually just use the regular expression thing here. No, words might be more readable. So we have space, we have sign, we have digit, we have dot, we have exponent, and we have some invalid stuff. So that's going to be the columns for this matrix, and which corresponds to the edges in the graph. We're going to have quite a few different rows. Each row represents a state, and the column represent by doing that edge to what state we can get transfer them into. So I'm just gonna put it here. So, delta state input IMP is gonna tell us the next state. So yeah, so the next state is gonna be by doing this. Or if you can think about this as a function, it takes the state and the input as the two arguments, and it return you the next state. So that's also a way to think about this. I'm gonna align this with the column name here. Some of the state that we have, just looking at the regular expression pattern, we definitely have a init here, which is before we starting to do any kind of matching. And we definitely have a space here. Oh no, we actually have a sign here. The space is when we see space, it's still in the init part, init state. So we have the this part. So when you see or in the regular expression, it means that from the previous state, we can actually try to go to two different paths. One is to the state represented by the first, the left stuff from the or. The other edge, the other kind of option is to go to the other direction. So we got like a digit and dot, two options. If we go to the digit route, it will be something like a 5 point. If we go to the dot route, it's the number that's starting with a dot. So for the dot, it's actually required that we have a dot with a digit there. And actually dot with digit, those two combined, it's equivalent to say that we finished the stuff here. I'm just going to call this number state. So it's once we have a digit after the dot, it's a valid number. And then we enter the optional exponent stage. It will be things. It's not all. It's a sequence of things. This should be 3 different states here. We see when we first see the exponent sign, that's one state. We have an optional e with e and sign state, and we have another one which is the e with digits. So that you can see that the e is a state, and there are 2 different nodes afterwards. One is the sign, and the other one is the digit. So the e will go to both, but for the sign, it has to follow it has to have a link directly pointing to this. Yeah, in interview time, when we have a whiteboard, we just draw the graph there. But here, I'm trying to do my best to explain this. I hope you get the idea. So e with e sign and e digit. I'm just gonna call it these 2 states. And after that we have end state, which I think it's when you finish everything and see extra space, or maybe the end of the string kind of a character indicator. We're gonna call it a successful ended, and let's actually just call it success. And we're gonna have another state called fail. So basically doing this is gonna be we start with initial state, and for every character we have, we're looking up. We treat every character as an input, just gonna transition into the next state. Doing a for loop through the input string, and in the end we want to find whether we are in the success or in the fail state. So that's pretty much the goal of by doing this. So let's just code down the number of rows that each will represent, each will be corresponding to one of the state that I laid out up there. If you have the regular expression there, it's not difficult to come up with the states. We got init, we got a sign. Just gonna do copy and paste. Some nice formatting so that next time when I see it, I still understand what the column and row means. Otherwise, all I would say is just a bunch of numbers. So this is init is 0, sign is 1, 2 is digit, 3 is dot, 4 is the number. Actually, I'm just gonna call this number. 5 is E, 6 is E with sign, and 7 is E with digit, 8 is success. We got one last line, which is the fail. So that's the transition matrix, delta matrix transition function. The states are called the state is called what? I forgot. I think the input are called sigma. State are called Q, right? In the notation. I don't remember. It's been so long. So basically, we can find that for the very last row, if we are in fail, whatever the input we take, we're gonna pretty much just stuck in there. So we're gonna have 1, 2, 3, 4, 5, 6, 9 in there. I should prepare this a little bit better than this. This does not look nice. I think you get the idea. If we are currently in a successful state, the only thing that we can still see, it should be space. If we pretty much determine this as a valid, valid decimal number, and we see signs, digits, dot, exponent, or any kind of thing, it should lead us to the, it should transport us into the fail state. The only thing that we can accept is empty space. So that's what this here says. I'm just gonna copy this, paste. You know what? The last row is easy. The last column is also easy. It's gonna be all 9. If we see an invalid, no matter what state we are in, we're gonna end up in the fail. So I'm gonna just go ahead and populate that out as well. So I do hope that we have a whiteboard for doing this. Otherwise, it's quite a pain. So let's look at the rest of the stuff from the beginning, I guess. If we're in the initial state, the only thing that we can accept is this 4. if we see an exponent, it will be the situations like directly a e up front. It will be not okay. So this is 9. And if we see a dot, we directly enter the third state. So it's here. If we see digits, we get into the second state number 2. If we see a sign, so it's pretty straightforward. You see, if we see a empty space, we're still waiting for the first meaningful stuff to happen. So it's a self-pointing loop edge. If we see a sign, we enter the. If we see a sign, we enter the sign state. If we see a digit, we enter the digit state. If we see a dot, we enter the dot state. Quite straightforward. So far, so good. Then if we are in the sign state, what we are expecting is we no longer expect a space. If we see a space, we should go to the fail part, and we don't want any extra sign as well. So that's what this example here says. If you have a minus minus, or if you look at the expression, it's one of plus or minus. We're not expecting more than 1 in there. So that's a 9. And if we see digits, we just go to state 2. If we see dot, we also go there. If we see exponent, it's the same rationale. It's not okay. So that's the transition function for the state sign. Then is the digits. The digits are what we're expecting is an optional dot or some more digits, or the exponent. So there are 3 columns here that should be non-9. So we will see, or we can all the way go to the back. A single digit number like 9. So this first column is actually 8. We succeeded if we have something like 0 space or 0 end of the string. We should go here. For sign, it's a 9. For digits, we still we stay at the same state. The dot will cause us to directly go to 4, not 3, but 4. So this might be a little bit tricky here. When we see a dot, we actually go to 4, not 3. Exponent, then we go to 5. So that's the state transfer function for the state digit here. Then we start populating this. For dot, what are we expecting? When you look at the regular expression, the only thing that we want to see is digits. So everything else should be 9. Only this column should be something. It will be the number state. It's 4 here. Everything else should be 9. And for 4, we're pretty much outside this OR here. The thing that we're expecting is digit, more digits, exponent, or empty space. So if we see empty space, we succeeded. So here's the 8. If we see sign, that's not okay. If we see more digits, we stay at the same state here. If we see a dot, that's not okay. Exponent, we go there. So that's the state transition function for state 4. And 5 is the exponent. We have 2 options, a plus and minus sign, the sign, or we see digits. That's the only 2 edges that we have. So for this row, we're gonna have most of those are 9 and 2 things that's not 9, which is the sign and digits. So for the sign, we'll go to 6. For the digit, we go to 7. Everything else should be 9. And when we add the sign, the only state that we want to go to is the digit. The only edge we have is this one. So everything else is going to be 9. Seven and 9. So here, the very last line here, everything that all the stuff that we're expecting is more digits or empty space. So it's 8 here, 9. This is a self loop, self pointing edge. Everything else is 9. Yeah, so this is the delta, the state transition functions, based on the current state and the input, which is the next character that we have in the string. This 2D matrix is telling us what's the next state. So with this in hand, we should just parse the characters by characters if in the input string, and in the end we want to see whether we are stuck in this success. We are in the success state. So initial state is 0, and we're gonna, for each of the characters, we're gonna convert that into the we need to find the columns basically. We're gonna write a helper function very soon to handle this. Convert this character into the column identifier and the updated state. So just taking this, I'm just gonna name this input. So in the end, we should return the state equal to 8, which is the successful state. We actually have early stopping. If any given time point that we find we get into the fail state, we should return false. And since I mentioned that this space also functions as the end of the string, so in the end, to make the case like just a regular number there, go to the 8 here, we do one final transition here. The input is going to be empty space, so it's 0. So this force us to go to the succeed, in whatever case that we have, just a good old integer number, or decimal number, or number with the exponent, or number with some more extra space. Both for different cases would be forced to go into the success state with this one final transition. So that's pretty much it. I'm just going to code up the conversion here. So if it's empty space, we should return 0. It's pretty much just looking up for this column numbers. Yeah, I'm gonna just node with numbers as well. If it's a white space, we return 0. If it's a sign, we return 1. If it's digits, Yeah, so it's pretty much just convert the input character into the colon identifier. And for each of the characters, we find the columns, we find the current state, and just do the state transition and do some final checks on the state. So that's pretty much it. Let me actually run this through all the examples and submit this as well. Yeah, so it's working. I'm glad that I'm not messing up at this graph here. So, ideally when doing real interview time, you have a whiteboard, you can draw this graph. It's not so messy, and actually most of the edges here are 9. If you choose not to draw the fail state as an extra state, if you only draw stuff from 1 to 7, that's also okay. You just identify some of the state might be potential, in the end, if it terminates, it should lead you to the successful state. I guess in the most simpler graph, it should be 8 nodes. A little bit better, a little bit redundant, we just have a 1 node to sync all the successful paths, and 1 extra node to absorb all the fail state. It should be 10 nodes on the graph. Depends on how you draw it. It should be between 8 to 10, and the edges are just the characters, and yeah, that's pretty much it. If you use this, you will be sure that you covered all the possibilities. Compared to try to reasoning through it and try to use if and else to cover all the cases. It's quite dangerous if you are in a real stressful interview settings. You're gonna miss a lot of things. The benefits about writing this transition function is one is that they know that you actually know how to solve this more robustly than writing a hand-wrote a bunch of if-else statement. So even if you mess up some of the number here, the interviewer might jump in and actually help you. But for if and else, if he's not really following you, he's not going to be able to help. And the other thing is, this gives you a systematic way of thinking about what's the state and what's the possible action, how I'm transforming from one state into another. So this gives you kind of like a systematic or framework way of reasoning through all the possibilities. So you are less likely to make mistakes in interview time. So I personally highly recommend this this approach. Yeah, so that's pretty much this question and my personal preference of how to solve this. I just don't think that writing a regular expression is what they are looking for. Because if you are expert in gurus in the writing regular expressions, you're going to finish this within 5 minutes, and that's not good. So yeah, so this is what I recommend. So that's it for today.